You're listening to Pardon the Disruption with your host, Tom Young.
Hey, thanks for allowing. Can everybody hear us in the back? Is this okay? We have the PA here to help out with the sound. You guys can hear okay? Great. So thanks for coming out tonight. We've done about 8 or 9 of these in the New York area, and we have about we put out about 70 podcasts this year on a variety of topics like this to help people go past the vernacular, right? So people hear terms like AI or edge computing or something like blockchain or quantum computing, but the topics are very complex. And oftentimes, even people in the industry are embarrassed to say they don't know. So we're going to presume that nobody knows what edge computing is. If you think you know, we're going to try to help expand your knowledge tonight about what it means and make it accessible so you can see some of the trends that are happening. So I'm happy to be here with Rob, my good friend. We did a show, God, it had to be about 2-3 months ago on winners and losers in the digital revolution. So thanks for coming here.
Thanks for having me back. I guess I didn't do too bad.
No, it was great. So, so Rob, you were at IBM Watson for a long time, and now you switched over to being having a leadership role in the edge computing division of IBM. Tell us a little bit about that. What is edge computing? What do you tell people when they ask?
Well, before I answer that question, let me just give you a little bit of background and rationale for why I switched roles. And it all began when I was looking around to see what else we might do with AI, and Watson in particular. And the first thing I came across was this sort of desire to bring AIs out closer to where data is being generated and where actions are being taken, meaning the edge. And as I looked across our portfolio, I realized that while this market and demand for being able to do this sort of thing exists and it was growing rapidly, we had no focus on that. So I switched gears and picked that up. So with that as background, edge computing for me is bringing workloads, typically those are AI and analytic workloads, but where the work is being brought to where data is created. And if you think about our world, where we live, what we do, our work at work, the things that we do at work, typically we're using equipment and devices that more and more often have compute capacity on it. And it's in that, with that equipment that we generate data. We actually enter data into the system, whether that is, the data coming off of the car, transmission engine, turbine engines, whether that's data that we enter in through our phones or through our interactions. Consider in your apartment, looking at the TV, the fact that you're changing channels, what stations you're looking at, how long you look at it, is data that can now be collected by the TV. That's where the data is entering into the system, and that's where there's a desire to be able to perform more of this work there.
So I came out of the telecommunications industry, and my observation would be that telecom lags compute in terms of its capabilities. So if I go back to the 1970s, you and I are probably old enough to remember some of that. You had large complexes that sat in data centers, and you had terminals sitting out there. And the advent of the personal computer moved a lot of compute to the edge back in the 1980s.
Yeah.
And telecommunications took a while to catch up because the bandwidth was one of the driving factors to move compute to the edge. Otherwise, you had performance issues. So if I had to, work through a communications link. So remember, a lot of people remember the modems, right? But at the early days of modems were acoustic coupler at 300 baud rate.
134 and a half.
134 now. I'm not that old. But the communications link for data, because the system communications was built around analog, was limiting.
Yeah.
And
fragile.
And fragile. And then we started to move to this cloud computing, which started to reconsolidate a lot of the compute. If you look at, even IBM's cloud services, AWS, Azure, even the Google complex, a lot of this, cloud in the aggregate's probably $100 billion. And now we're starting to see with IoT, smart devices at the edge, just like the PC drove it in the 1980s, we're seeing IoT drive the need to have compute and processing of data locally, right? Because 5G is going to promise a lot of the, but it's lagging what is going on with compute.
Yeah, I mean, if we really want to be complete about it, this pendulum has been swinging back and forth for decades, as you point out. I mean, we had in the beginning mainframe, centralized computing. As you said, we brought in PCs, and that kind of created this client-server era. Subsequent to that, people kind of got really nervous about what it took to administer these PCs and keep the software up to date. So that kind of drove some of the web application computing kinds of things that were going on. Then we saw that reverse begin with mobile phones and distributing our applications onto these phones. Now you're seeing the introduction of growth back to cloud-based computing, which is a centralization again. And now, as you say, with edge devices, and I make it a little distinction between an IoT device and an edge device in that IoT has had for such a long period of time this property that mostly is about sensors and actuators, and the idea that we're going to take these things and connect them back to the cloud. Edge computing being really about the introduction of compute on these devices. And you're right. I mean, these traditional IoT devices now have real compute on it. They always did, but now that's being opened up.
So help me with that, because this will be a good educational. What is it if I think about a smart device versus an edge computing device? You're saying they're not the same thing.
No, I'm saying an edge device is smart. IoT devices have for too long been known to be not. Right. And so we make that distinction only to
So in my home, what would be considered an edge device? Would it be a cable set-top box, a TV?
So if you look around your house, you're going to find your TV, your set-top box. Actually, interestingly enough, your cars, if you have one, a typical car today has about 50 CPUs on it, 50 computers on it. So it's actually a miniature, supercomputer running around on wheels. We don't think of it that way, but that's what it is. Actually, light bulbs. GE and Sony both, their high-end LED light bulbs now are being made with ARM chips. So your light bulbs have compute capacity.
And what are they processing locally?
Well, they use it first of all to kind of control the hues. So if you want to have kind of a smart way of controlling the light volume and color, but now they're adding speakers to the light bulb. So instead of having a stereo at home, you'll just simply Bluetooth connect to your light bulbs. There'll be an array of those across your home, and your sound will broadcast everywhere that you go in your house.
Wow.
Now, by the way, those are highly insecure. The largest denial of service attack that has ever been launched in the globe was launched from about 1.5 million light bulbs. People hijacking these light bulbs and putting rogue software on it. So that's an issue. Security is a major exposure right now in the edge computing space.
Yeah, I would think.
Yeah.
Yeah, I mean, the race for functionality to differentiate yourself often leaves the security guys behind.
Yeah, well, people do run ahead of themselves sometimes. But, it's not even just at home. It's really almost everywhere.
But how about, I have a security camera system I bought, I think it's Blink, right? It has a hub.
Yeah.
And it processes stuff wirelessly.
Yeah.
And then that interface is through the Wi-Fi network. And my guess is it's completely insecure.
Could be. But, that's another example of intelligent devices are the cameras, these smart cameras that you have at home. Actually, thermostats, right? Of course, Google had bought Nest. They've let it go now, or they've changed Nest to something different. They've let the thermostat business go. But that was all, based on there's a computer inside your thermostat, and they're going to do some interesting things there as well. At home, but we also have to think about the world that we operate in. Again, speakers, microphone, or cameras. At work, virtually every modern piece of manufacturing equipment is made with computers on board. In hotel rooms, we're seeing now people deploy these devices in the hotel room that sort of sits on the side table, almost like an alarm clock, but it's a voice-activated device. You can go up to it and talk to it and ask it questions and use it to control the room. We think there's about 15 billion of these in the marketplace today. 15 billion devices that have compute capacity on it that could be used for.
So let me ask you. So these edge devices, they're intaking and ingesting a lot of data, and it just makes sense to, if you can process it locally, it's an engineering decision. It just makes sense to do it there, and then send the signals the distillation of that processing up the line so you can see it at the aggregate level. Is there an architecture, and is this part of your edge computing, where the edge devices become slaves to the cloud and are processing things that aren't related to that device?
There is some discussion about that. They call that fog computing. I don't really subscribe to that. I think that the economics are going to have to shift quite a bit before that becomes a real viable alternative. But yes, absolutely. Roe made the point that only about 10% of the data that is being produced is actually being processed at the device, and that's going to reverse over time. I'll give you a different statistic. Of all the data that's collected by these IoT devices and brought to the cloud, and this is universal across the industry, only about 1% of that data is processed to have any sort of meaningful output. So that says there's a lot of data that's going into the cloud that is essentially being ignored, lost. And there's a variety of reasons for this. One of them being that the data you get is just messy data. It's just, meaningless data. It's the same signal coming off of some sensor someplace that's been repeated 15,000 times, and you only needed to know that once. You only needed to know that the door was opened one time for you to do anything. So there's a lot of redundancy in that data, but there's other reasons. Now, the problem is not just that there's more data being put out there that's not useful, but your ability to do anything with it is conditioned by things like latency. If it takes 250 to 500 milliseconds to get a piece of data up to the cloud, processed, and then a response sent back, that may not sound like a lot of time. That's a half a second. In human terms, that's not much. But that's the difference between somebody recognizing a little twitch in somebody's eye versus really thinking about something deeply. And if our interactions are now dependent upon these sub-millisecond interactions, responses, we're not going to be able to do that by sending the data back to the cloud.
The driverless car.
Driverless car is another one, right? You got a kid running across in front of you. That 15 milliseconds that it takes to respond as a human is the difference between that child living or not. If you're going to use a video analytic to recognize these kids, you better process that well. And by the way, you're screwed if the network's down, right? If your car is not connected to the network at the time that you're doing this, if you're doing that at the cloud, is a bad idea. So you want that locally.
So part of what you're doing is also deploying logic beyond simple processing, right? You're putting
a lot of it's analytics and AI,
AI kind of stuff, machine learning. So the devices you're putting out are getting smarter. They're attuning to your behaviors and your data sets. Is that fair?
Personalizing, yeah, sure.
So how will that manifest?
Well, let's give an example of driving. Cars. Today, the car will give you a light that pops on when it needs service, right? When your oil needs to be changed or whatever. That light is conditioned on the assumption that everybody drives the same way, right? So after 3,000 miles, the light's going to kick in and tell you to go change your oil. That's the same for everybody. The reality is that we don't drive the same. Our road conditions are different. Our driving behaviors are different. All of that is, if we really want to get optimal maintenance of our car and change the oil at the right time, sometimes it may be less than 3,000 miles. Sometimes it may be way more. If we can build an algorithm that is adapted to you and your driving conditions, your driving preferences and behaviors, that will tell you when to change your oil based on you, as opposed to the 3 million other people out there driving the same kind of car, you're going to get some optimization that way. So that's just a small example, but that's the kind of optimizations that we can do, the personalizations that we can do on these devices.
So are you guys dealing with any? We did a podcast recently on the sort of the ethics of the logic that goes into some of these AI devices that are making decisions that humans used to make. So we use the driverless car as an example. The car is beset with a choice that is not an ideal set of choices. What decision does it make, and what does it optimize on? Does it optimize for the car manufacturer? Does it optimize for the people in the car? Does it optimize for society?
Or is it trained and optimized to what it's been trained to do, which may be a function of the driver's preferences, the road conditions, the local regulations, et cetera, et cetera. I don't think that those issues are any different. I mean, they still exist. They're still as important in the context of edge computing as it would be in the case of cloud computing. The same problem would exist even if we did that same algorithm in the cloud. On the other hand, if we can take it away from that scenario and take it to driver safety, right? If the car, because it has LiDAR on it, because it has local processing on it, can recognize that the car's two car lengths ahead are slowing down and help you avoid hitting and protect you in that way, that's a benefit. So yes, there will be trade-offs. There will be occasions where we've got these real moral dilemmas we have to solve. In other cases, there's going to be lots of opportunity to benefit people in ways that we couldn't do before because of things like latency and bandwidth.
I bought a car this past year that has lane keep assist and active cruise control or dynamic cruise control. And you put those two things together, and you get on the highway, it's like it's autopilot.
It is autopilot, but the thing that I noticed, because I had one like that too, is driver fatigue is lower, right?
Yeah.
So I'm actually more alert. I found in my case, I was more alert with that because I wasn't using my brain to deal with every micro decision that goes along the way, including things like slowing down and speeding up. The car was taking care of that for me, which freed my mind now to concentrate on the bigger picture. What was the traffic situation like that ahead of me, or
right.
What might be happening in different circumstances. And so, again, good example where we could always identify what the moral dilemmas are, but there's lots of benefits that come from these things.
So go back to what Rohan said at the outset, with very little being done at the edge today, and in a few years, it'll be a lot more. Let's say it goes to a majority of compute is done at the edge. Do you believe that's true?
So if we go back to history and all these examples of where we've gone through this pendulum swing, central to decentralized, back and forth, every time we've gone through that cycle, what we've seen is more and more traffic being generated going back to the central locations. We saw this with client server. We saw this with mobile phones. I mean, we think about these things being fairly autonomous. We build our phone. We add our own apps. We decide what we're going to put on there. Behind the scenes, every one of those actions is being supported by some transaction in the cloud. So I think the same thing will exist here too. Now, hopefully, what gets put back into the cloud, the compute that gets done there, is more valuable, is more effective, because the data has been cleansed, because it's been filtered, because the preliminary decisions have already been made, and now what we're getting is the aggregate. So I think the utility will go up, but I don't think the traffic will go down.
So what do you think the challenges are for today for, businesses who invested a lot in their compute platforms and are looking at, oh my gosh, a pendulum swing. What happens to my capital investment?
Yeah, I would turn that around to say, what are the opportunities for innovation? And I will liken it, and I made this analogy before. In fact, in the last podcast we did, I talked about this. And if you think about where we were 10 years ago with these, when these first came out, nobody really imagined what we would be able to do with these iPhones and how they would transform our lives. Right. And not these iPhones, but these smartphones. And how they would transform our life. And yet you look at what we do today and how we conduct our daily activities, and it's very different. The innovations that have been introduced, the opportunity to do things that we couldn't really think of or imagine doing before have occurred, and I think the same thing is going to happen here. Yes, businesses will be impacted by that. That will be a shift in capital investment, even operating expenses, et cetera. But I think the opportunity to grow value, to be able to do things for people that couldn't be done before, to be able to operate with levels of efficiency that couldn't be done before, to be able to do it with levels of insight that give people more freedom, more choices. I think those are all outcomes.
Do you think that and people are going to have to be more educated about this in order for them to participate? Because let me get to the heart of the question. In the corporate world, there is the IT organization that manages the compute for the organization in a large extent, and as you move compute to the edge, it's akin to a democratization or a dispersal of that into the organization. And the organization is going to have to be somewhat proficient in understanding the capabilities, the nuances, the configuration, the operability of those things in order for it to be effective, or they're going to have stuff done to them that they may or may not want or consent to. Is that fair?
There's probably going to be some of that. Let's start with the most basic scenarios. And let's take a train station, for example, where at that train station you have a bunch of ticket kiosks, right? Think about the subway stations here, for example. Those ticketing kiosks have software running on them. And today, the transit system, in order to update those ticketing kiosks, are having to go out one machine at a time, stick in a USB stick. They take the machine down, they stick in a USB stick in some port at the back of the machine and upgrade the software. And they do that station by station, machine by machine. In the future, with edge computing, that will be a central task. And so that from a central location, you'll be able to deploy the workloads that need to the upgrade, the software upgrades that need to be made on those machines. To do that, certain things have to happen. Number one, the machines have to be online. They have to have the means by which we can do that kind of remote management. And there has to be some degree of standardization around the software packaging that enables us to do that consistently across many different kinds of machines.
Like what?
Well, it turns out that the cloud has done a lot of work for us here. The cloud has already begun to transform the composition of software around what's called containers.
Kubernetes.
Kubernetes, Docker containers,
All
right? And every major cloud provider out there today has standardized on the idea of Docker containers and using Kubernetes to do service orchestration. Because of that, almost all software today is developed around the container concept. Modulo those that are done with VMware and VM images, but the rest of it is all kind of standardized, which enables then this capability that doesn't require this massive re-education of the workforce to be able to handle
let me hit the reverse button here so we don't go too deep into the weeds here. When we talk about cloud computing, the advent of this was we took a physical server, and whatever the XYZ 123 brand, and we took it and put it into the cloud, and we software emulated that server. So the software developed on that server that had all the nuances of how that server worked and how it managed memory and all of that was done. And now I just emulate that in the cloud. And what happened is once those things became resident, you're saying, well, why are we doing that? If it's here, let's just break it down to its elemental parts. And that is the containerization. So when we talk about containerization in cloud computing, it is breaking down the emulation of servers that used to sit physically in a data center that now sit in the cloud, and we broke down those containers. And the protocol for breaking into containers is Docker and Kubernetes and things like that have a standard approach to it.
Yeah.
And when we break it down to its elemental piece, you get into a situation where the notion of a server downtime goes away. It doesn't even make sense.
It's all virtualized. Yeah.
It's completely virtualized. Yeah. So I could have a physical server go down and I have to reboot it, but I could also have a virtual server go down and reboot because it's emulating that physical thing. But once I move to a containerized, it's totally different.
Well,
is that fair?
I think of containerization as being a further decomposition of the virtual machine. So if you had a piece of software that's running in a virtual machine, a virtualized version of the physical machine, and as we said, the benefits of that being that if the physical machine goes down, I can take that virtual machine and rehost it on another physical machine, and it's almost like it never went down to begin with. But what containerization does is allows us to further that decomposition into even more fine-grained components, which gives us then the flexibility to start and stop those things, not even on the same virtual machine, but across multiple different virtual machines. Same principle applies here in edge computing. So we're leveraging that evolution in cloud computing to enable edge computing, which, to your question about skills, dramatically reduces the barrier to entry.
So does containerization enable more edge computing or less? Or is it irrelevant?
Well, it enables more in the sense that it allows us to take the artifacts that we've already created for the cloud and now rehost those in edge computing spaces.
How about 5G? A lot of people talking, hearing about 5G, the next generation of wireless networks, very high speed. Is that? I assume that's a huge enabler to edge computing.
It is, but it's also a driver of edge computing because there's a great big lie behind 5G.
What's the lie, other than it gives us cancer?
Yeah. 5G promises to reduce latency and to increase bandwidth. It also introduces some ideas around network slicing. But for latency and for bandwidth, the problem is that when they talk about reducing the latency of 5G from 4G, you're talking about a difference of about 5 milliseconds.
From what to what?
So 4G takes about 9 milliseconds for your device to connect and communicate to a cell tower. So that goes from about 9 milliseconds down to about 4 milliseconds, which sounds like a big deal. But remember what I said earlier, right? The end-to-end round trip from your device up to the cloud is 250 to 500 milliseconds. So reducing 5 milliseconds out of 500 is hardly recognizable. And this is not because anybody did a bad job of engineering. This all has to do with laws of physics. It has to do with the speed of light. The distance
and router hops.
Router hops kind of slow that down even worse, right? But even if that wasn't an issue, it would still be, you just can't get the electrons moved from your device over the 1,000 miles to the cloud compute center and back again any faster than that, electron will move. So to really fulfill the promise of 5G lowering the latency, you've got to move the workloads closer to the device.
Right.
Now the networks, you brought that up earlier, the network providers are now all starting to transform their network infrastructure to host edge computing in their network. So, in the central offices in the middle of the city center, in hub locations throughout the rural areas of the country, you'll find these places where the network providers have set up compute space that will now be able to host this stuff to get it closer, reduce that latency, and fulfill the promise of 5G. Same thing's true with bandwidth too, by the way. So yes, it will increase the bandwidth from the device to the cell tower, but the backhaul is still resource constrained. It's still network bandwidth constrained, especially from the network to the enterprise. So, the only way you can fulfill that again is by moving the work closer. Now they won't go, that's to the network edge. We're talking about going even further, right, into the servers and the devices in the premise.
I worked in the games industry 20 years ago, online games, and obviously the technology was nowhere near what it is today. And latency was the huge issue for fast twitch games. Yeah. So we could do bridge and card games, solitaire, things like that didn't require low latency, but a fighting game or one of our games was NASCAR Online. It just didn't work because you needed something much less than 300 milliseconds, and we couldn't do that back then. And so today, that when I read about 5G, they're talking about latency going down really low, but it doesn't sound. It sounds like what's the major reduction when they say 50% reduction, it's reduction to the cell tower, not reduction end to end.
That's right.
Yeah. So why are they spending so much money? Because I work with AT&T, Verizon, and British Telecom. Not so much BT, but AT&T and Verizon seem highly distracted on the whole 5G issue.
So one of the things that is of interest, I think, to me about the economics of 5G is that it disproportionately advantages businesses. So if you think about 3G and 4G and LTE, we as consumers benefited from those advances, and we largely benefited from them in our mobile phones and a little bit at home. 5G is going to advantage enterprise compute in the form of I no longer need to have a network connection into my factory. I can just simply wirelessly connect my factory equipment, my controllers, automobiles as well, which is a variation of consumer, but it's a little bit more industrial. And so all these use cases where an enterprise can benefit from 5G is the primary economic driver behind it, right? If you think about the telcos, they've just become a commodity pipe, mostly to consumers, and we don't like paying very much for our network. So we're driving as consumers the price down. 5G, we can now get this economic benefit out to enterprise organizations. They're willing to pay because of the value that brings. So that's going to drive 5G.
Yeah, it seems. I come out of the telecommunications industry, so I stay connected to it. But they seem awfully distracted by this whole industry trend, and I look at the amount of bandwidth that we have already and how it gets used. And at some level, it's like, what else the hell are you going to do with it? I mean, if you stream 4K, you need 20 megabits, maybe 25, but you don't need 10 gigs.
They're also scared to death of Google and Amazon. who are out creating their own network capabilities. And, at some point, we're not going to need the telcos. We're going to be able to bypass them. So it's an interesting.
We're already seeing that. I think people under 30 don't have landlines.
Well, that too, right?
Right,
Yeah.
and
but
then
we won't even go to them for our internet service either.
Yeah.
Right. We'll go to the Google Fiber and go to Amazon setting up networks through all the Starbucks out there. But the point is that I think the telcos feel like they've got to go re-engineer their business models. And it's no longer going to be about being a data pipe. It's really going to be about a service provider for enterprise functionality.
So as the people in the audience here are looking at the topic of edge computing, and they want to see, indicators of, if you use a garden metaphor as I'm growing stuff, I want to start to see the stuff to grow. Mm-hmm. What should they look for to say, is this moving faster than I thought or slower than I thought? Mm-hmm. What should they look for?
Well, I think what you're going to see, first of all, let me back up. So for edge computing, as I've already indicated, edge computing is already here. It surrounds us. We're not even aware of it. Virtually every piece of equipment in this room has a computer in it, and it's open for being used, ideally in a protected way. But that TV, these cameras, the projector, all of these things have computers in it. Of course, our phones have computers in it too, so that's another form of edge computing. So edge computing surrounds us already. We're just going to see that continue to grow. We'll see other manifestations of value coming out of that capability. Smart TVs that are able to anticipate what we're trying to see and get us to the right station faster. Switch the channels, for us automatically between commercials and stuff like that. On the vehicle side, all the major automobile manufacturers are re-engineering and re-architecting their cars, and you're going to see the introduction of more advanced capabilities around driver safety, around personalization, around roadside assistance. And what I mean by that isn't, your car broke down, how do I get assistance? What I mean by that is, if your car can be informed by the roadside about traffic, about weather events, about points of interest, and feed that back into your car, not only can that help you as a driver navigate to where you want to go more efficiently, but it can enable your car to operate more efficiently as well, by anticipating what's going on. Roadside, the sign that tells you what your speed limit is, that's going to go away someday. You're not going to see speed limit signs. You're going to see on your dashboard the speed limit of the road you're on, because it's all going to be electronically connected. So you're going to see some advances in automobile stuff pretty quickly, I think, over the next couple of years. The vast majority of edge computing is probably going to surface in more of the business-oriented scenarios. You might find it at the store, more self-service point of sale. You're going to start seeing more and more robots doing inventory checking. You're going to see the stores using cameras to do spillage and spoilage alerts. You might find it in restaurants.
Yeah. We tend to, a lot of times I get asked questions by people about whether this is good or bad, utopian or dystopian, and I almost always devolve back to, it's going to be a tale of two cities. Mm-hmm. And it really depends on how you view it. So, so an issue of privacy, like I bought those Blink cameras, and I have cameras in my house, and you say, well, I lose privacy when I do that. But at some level, I say, well, I'm the beneficiary of this at some level, because I can see when rabbits are in my garden, because I have one of my cameras in the garden, or I could see who's in the pool if I want to do that. So it really depends on how you look at it, and then also it depends on how we approach this as individuals. Mm-hmm. So tell me how you're doing in the new job. I know you came from the Watson, now you're in this new area for a few months. How are you doing on talent? I mean, is it hard to find talent?
Yeah. I mean, other than the fact that, as I said before, we are borrowing from pre-existing technologies. And so if I'm an administrator and I've got responsibility for all those devices, and I need to make sure the right algorithms are on those devices at the right time, I can't do that by going one machine to the next and installing that right algorithm. I've got to find ways of automating that. So that's an example of what
that's
I mean.
That's like selling jet fighters to taxi cab drivers.
Okay, but it's also it's also a matter of fatigue, right? Because after the 100th time of saying I want this piece of software running on that machine, you start to get tired.
You just described the sophisticated, and the guys who are an operator of a mall or a large building are typically don't have that level of sophistication. I mean,
no,
typically.
That's right. But they also get tired, and they start making mistakes.
Yeah.
A few of them. Diversity, all these devices are different. The things that are common, they have the same kind of processor on it, but they're different sizes. They different set of, sensors on them. So a lot of diversity there, but they're also very dynamic.
Yeah.
So, if a device gets moved, if Liam decides to move that TV somewhere else, that movement could actually affect what algorithms should be on that TV. Maybe he doesn't do that very often. Maybe he only does that once a year, twice a year. But if you got 10,000 TVs or 100,000 TVs or other devices, just the multiplying effect can make that world very, very dynamic. So all those things are creating a lot of complexity, and trying to find the right skills for that is not easy.
So let's. Why don't we open it up to questions? Rohan, you want to see if there's any questions out here?
Yeah.
While we're doing questions here. Yeah, question from the audience here?
Mm-hmm.
Yeah, sure. All right, so with one of the promises of 5G being low latency, high bandwidth, node-to-node connectivity for devices that are within close proximity, it looks like we're starting to see an emergence of distributed edge computing, with one of the most notable use cases being car-to-car communication, being able to signal to each other that maybe there's a hazard down the road. So this is a two-part question, right? What are some of the other potential applications leveraging this new paradigm of distributed edge computing? And then the second question is, do you see blockchain technologies evolving to take advantage of some of these new paradigms in edge computing and distributed processing?
Actually, let me give you an answer that I think hits on both of those questions. You may have read recently about some of the food safety work that's being done, Maersk, Walmart, some other people that are getting involved with trying to be able to trace food from farm to table. Think about the bananas that you just bought, or whatever produce you just bought. What farm was that grown on? What if there's a outbreak of some disease or something on that, can you get back to what farm that was produced at? With blockchain, the promise is that we can track that food all the way back. I forget what store it is, but one I just saw recently, you can literally go up to the produce counter and scan it, and it'll tell you what farm that cabbage or whatever was grown on, when it was harvested, and what path it took to get there. And you can do that through an app on your phone and scanning the product. So that's the kind of promise that we have. The problem is farmers don't have IT equipment on their farm. The average farmer, knows how to milk cows, doesn't know how to install, a server rack and use that to then register the food that they're growing on that farm. Now, some do. I mean, certainly some farmers are getting more advanced, but that is still a small percentage of all the farms out there. So if with edge computing, we can bring to that farmer a device that does not require any IT skill. This is a device as simple as a phone. That has the software on it that will do the scan and register that product with a blockchain, and do that automatically so they don't have to worry about it, where the software on that device is being managed and administered remotely from some co-op or something that's distributing that software. You hit both, right? You hit both the advantages of blockchain and the advantages of edge computing in that space. And it may be 5G connected.
I'll tell you one area where I think we're going to see edge computing really impact significantly is on cybersecurity. So on our firm, we've done some consulting with some of the telcos on cybersecurity protocols, and most firms are still beset with perimeter security. Meaning perimeter security is password authentication, maybe two-token authentication factors, but once you're in, you're in. If I want to do, so a lot of times you'll hear this phrase, identity is the new perimeter. And as I look at edge, as I look at cloud architectures and then moving out to edge computing, the boundary gets hard to define. So people will say identity is the new boundary, right? And so when that's the case, you want to dynamically measure identity through a variety of mechanisms, not just at the point of entry, but dynamically throughout a session. So that could be the way you type your keystrokes, how fast you're typing, the things you're doing, the session, the location you're at, a whole bunch of myriad of multivariate stuff that needs to be processed probably locally just to be efficient so that you don't introduce performance issues. Because if I start introducing dynamic identity and access management and I reduce user experience because I have to transit up and down, even if it's fast, it's going to slow things down. So I see cybersecurity being a big area to deploy these new protocols of dynamic identity and access management to security protocols.
There's a very interesting local example of doing that here. Cindy and I just recently got one of these intelligent scales. And so I get on, and every morning it tells me my weight and how much more I've gained that day and how much water I've drunk and what my BMI is and all kinds of interesting information that it calculates in some ways that I don't really understand. But it's able to tell the difference between us, A, because it turns out I weigh a lot more than she does, but by the similarity of all these properties about me and who I am and my biometrics that distinguish me from her, and it's able to recognize that and use that to say, okay, this is my weight change. You know, I didn't suddenly gain 140 pounds because of the weight difference between us, but you know, because of these other properties.
That's pretty neat. Any other questions in the audience here? Hey, how we doing?
Hey.
How you doing? This sounds a lot to me like when websites started using the processing power of our laptops and caching stuff a lot more efficiently. Am I right there?
Yeah.
Similar analogy?
Yeah.
Okay.
Very good analogy. I mean, you know, it's this excess compute capacity that now exists on these devices that they want to take advantage of to do things that it couldn't do before, including analytics.
So if that's true, then will we start seeing this on websites and stuff like that? Or like ESPN or like CNN start using edge computing to serve up the website?
Yeah, well, all right. So remember I talked a little bit about how the network providers consider their network infrastructure to be part of the edge as well. And we're already seeing Netflix, for example, will position the video streams at edge servers in the network as a way of reducing the latency and to be able to maintain a higher throughput to your TV set, as an example. So yeah, you'll see some examples like that as well. We don't generally classify laptops as an edge computing. I think in some abstract sense you could argue that it is, but we're really more focused on devices that we didn't normally experience as IT equipment that now has been augmented with compute capacity that makes it better.
So think of these pendulum swings is the management of algebra, right? So there's the algebra of compute and the algebra of telecommunications. And when I worked in the telecom field a lot, some of the things we were doing around video caching was we were moving like website information out to the edge so that it was cached at a node that you were connecting to versus all the way back to the hub. So it was, you think of it as a multi-layered, you have a central core, and you might have 10 or 15 distribution nodes, and then I would hit that node. And the core was just managing the information back and caching it. So like, for example, when you do a Google search today on the internet, you're not actually searching the internet, you're searching Google's copy of it. And that just becomes an engineering decision. And so, at some level, if I break this down, I just say the edge computing is the outgrowth of the changing algebra between compute and telecommunications. To make whatever makes the most engineering sense. Yeah. And as I deploy smart devices with lower and lower cost integrated circuits that are computer based, right? That have a lot of power. I mean, everyone talks about NASA just had their anniversary. The amount of power on the iPhone is multiples of what they use to launch to the moon. And so as I start to deploy those things in every device, it makes sense to use it, and not to ignore it just because we ignored it before, because the devices were dumb, and now they're smart. So we're going to change the whole engineering around this thing for the better.
There's one more thing that we ought to bring up here, and you kind of hit on it earlier, but I want to kind of get back to it and make it real clear. We talked a little bit about data privacy and the security issues associated with edge computing, and yes, there are attack surfaces associated with edge computing that are, that need to be solved. But every time I enter a piece of data into a device, whether it's my mobile phone or anything else, and that data now flows up to the cloud, maybe it flows to some, IT data center or some service provider somewhere. Every time my data about me flows to somewhere else, it creates an exposure that increases every time we move it. So moving data around actually creates a real threat to exposing our personal information. If with edge computing, we can bring the work to the data, and the data was entered on whatever device you're touching, but the algorithms, the analytics are performed there, and the data doesn't have to move, it actually makes our data, the data that has been collected, for whatever benefit we get by doing that, more secure.
Yeah, well, and I would say overall, from an engineering perspective, the entire system is more resilient.
Mm-hmm. Well, of course, right.
To the extent you're distributing, workloads, you don't have single points of failure.
Yeah, and you can keep on working even when the network's down. Right.
Any other questions? I got a quick little plug here. You see the cards out here. We have a book coming out called Digital Labor, the coming demise of the white collar worker. Anyway, we're trying to get this out, in the next couple of weeks, and the purpose of this book is really to introduce. It's not really for technology insiders. It's mostly for what we affectionately call normies. To let them know that the impact of these technologies are going to impact white collar workers in a way that people, I think, are not ready for. What comes out of that is I don't know the answer to that question. But we do posit some of the things that people should be doing. Now, Rob, you just came out with a book too. You just recently published it. What's the title of your book? Yeah,
it's a book about Watson. It's something that I co-authored with Tan Mei Bakshi, and I encourage all of you to look up Tan Mei on YouTube in particular. He has a very strong following, has a wide variety of YouTube videos that he wrote, that he's produced. Tan Mei today is 15 years old. He and I started this work together when he was about 12.
Wow.
Off the charts, brilliant kind of kid. So I encourage you to go learn more about him. But he agreed to write this book with me, and we just published it.
That's great. We were just over at Watson Center yesterday,
Yeah.
and we were there for some meetings with IBM, and we were in the customer experience center, and they showed us what I thought might be an interesting, the next generation approach to sort of what I'll call a post-Google curated internet experience, where you're using analytics from Watson to drive, what is the sentiment around the globe, and then to be able to pick keywords and topics and show where they're hot, where green, yellow, red sentiment, with the geography issues, and then be able to really dive down and turn and take control over it versus being spoon-fed from either a Facebook feed or a Google feed in terms of what you're looking at. If you look at like Google research, you do a Google search, it's one of the first 2 or 3 terms or what gets clicked. No one ever looks at page 5. And page 5 may have some interesting things there. So when what was presented to us yesterday about the Watson stuff, that was a pretty good user interface. I haven't fully thought through some of it, but I think that there's some real opportunities to change the nature of the way we interact with the global information explosion that's happening right now. And as we look at edge computing and IoT devices being put out there, we're going to see an explosion of data that's available to us, and we're just beginning to start to figure out how to use it and how to make our lives better.
Yeah. So for my Google friends in the room, I don't want anybody going away thinking that IBM's going to take out Google yet. But I do think that internet search is prime for a different experience. And it's no longer should it be about finding the document that most likely has the information in it, but it's really about finding the information you're interested in. And if we can change that paradigm to be more focused on getting me the results of the questions I'm asking, and away from I just gave you a list of 100,000 documents and you figure out which one of them has what you want in it. I think that would be a major move forward. I think Google actually is doing some work in that space if you look at their knowledge graph work, but there's a lot more that could be done.
Great. Well, Rob, thanks for coming out tonight. Appreciate it. We'll probably do another series of this in a couple months. We'll talk about a new topic. I want to thank everybody for coming out tonight, and we'll have a few more cocktails. If you guys have any more questions, Rob and I will be here afterwards to talk to you guys about it. We hope, the purpose of these series and, our podcasts, et cetera, that we put out, and you can go to our YouTube channel, at Rumjog channel. We put out about 70 shows this year. This will be one of them. We'll put this out probably in the next 4 or 5 days. But we're trying to make technology accessible to people, and to deconstruct it in a way not just for the normies, as I mentioned, but also people in the industry. Because I often find, it's my job to be expert at a lot of these things, and so we invest a lot of time in studying these topics so that we can break them down. But I even find people in the industry. They hear the words, but they don't necessarily fully understand and appreciate it. And oftentimes they get embarrassed, and there's nothing to be embarrassed about. The information here is moving, the topics are moving so fast that it's very hard to keep up. And there's nothing wrong with saying you can't keep up. And, while, I write this, the book title of the book we're coming out with says The Coming Demise of the White Collar Worker. I will say this. There is not enough seats on the bus that's leaving the terminal, but there's seats on the bus for everyone who raises their hand. And the issue really gets to the point of people will simply not opt in. Now, the fact that everybody's here tonight suggests you're interested in the topic, and I would simply say that if you apply yourself and study, there is an opportunity here where you're going to explode in your career opportunities and your ability to have a successful life. So my encouragement to everybody is to pick something they're passionate about in this space, whether it be this particular topic or one of the many topics in technology and advancing technologies, and to go embrace it and learn it, because you'll find very quickly you're going to become an expert and you're going to become valuable in today's market. And that's my real passion for doing this, is I want to extend this. I want more people to participate and more people to be successful. So with that, thanks very much.
You do. Thank you,
Thanks,
Tom.
Rob.
Appreciate it.
Hey, thanks for listening to Pardon the Disruption. We'd like you to subscribe to our podcast if you like it. You can find us on most of the platforms where you get your podcast from, whether that be iTunes or YouTube or whatever you're on. We also want some feedback. Which shows do you want us to cover? What do you like? What do you not like? So that we can do this. We're doing this for you. We're not doing this for anything else. So please subscribe and give us some feedback. Thank you very much.